Our speaker tonight, Bill McDonald, started his career working on energy analysis and retrofit of existing buildings. His experience with the state of existing buildings, along with exposure to European building techniques, including passive house, set him on a path to develop a better way to design and build homes. He founded the Phoenix Haus to embody that process. And so with that, Bill, I would like to turn it over to you. Thank you very much for joining us tonight.
Absolutely. Thanks also for the invite to be part of the event and to be part of SECRES. Thank you so much. Well, I'd like to get started this evening and just talk a little bit about maybe some definitions and some terms. What really is healthy housing and what is our company about, just to describe the context of our current industry, along with some industry stats and how we really go about our business model to design and to produce offsite building packages focused here in the Rocky Mountains. So this is actually a picture of a recent installation this past summer in Winter Park, which is a really nice setting. I'm going to click here. So a little bit more about us, just briefly as a company. Again, we're Phoenix Haus. We're based here in Western Colorado. We're located in Grand Junction. And what's unique about our company is that we're formerly a manufacturing facility. We have an entire production and a small design team in-house. Truly, the business model is where we're connecting CNC integration, so computer-aided saw technology, with a formal offsite production facility. We'll talk about how does that have an impact on the construction of the houses themselves. But that's who we are, and that's where we're located. As a company, we'll be moving into a new facility here at the spring of 2022, which we're excited. So stay tuned with some updates as well with that. Phoenix Haus mission statement is a lifetime of healthiness achieved through housing. And so we knew that starting out as a company, we really wanted to, benchmark or underpin the business model to really the most stringent building performance standard to build and to design and build homes. And for us, that's a drastic reduction in energy consumption, which really lends itself to the ability and addition of like renewables and covering a construction or a home's energy consumption with a small addition of solar, just looking for a net zero status, which we'll get into. Some definitions that help going through today's presentation are the words prefab and healthy housing. For us, prefab is typically going in the industry as offsite construction is typically referred to, or panelized building, even like you've heard of maybe as SIPs construction or SIPs. We also kind of get grouped into or described as like modular building or 3D volumes or manufactured housing. For us, we're a little bit of all of those things. We're pre-designed digital fabrication of a building, a single-family home. We go more by off-site construction or panelized construction as an assembly. Furthermore, on healthy housing, what's a good breakdown of what healthy housing means for us? It means these things. It means wood-based and acrylic-based materials, so we're not using things like spray foams or oil-based tapes or membranes. We focus always on an airtight assembly with an integration of a fresh air ventilation unit, which we'll talk about today. And then super insulation, so a continuous exterior insulation is really important to us, and the style and design of the product. Also allowing for, of course, the integrations of electric-based heating systems, which we find is the fastest track to be able to offset energy consumption. And finally, integration of multi-use scenarios with single-family housing, even so folks can do co-housing, co-living, or like multi-generational housing these days. With the affordability of housing being a key metric, looking to find ways to utilize the investment more than just one single use. A good way to sum up the current approach for how we design and build is this emphasis of getting away from fossil fuel. So instead of focusing on heating systems, cooling systems, mostly heating, if you're working with a natural gas or propane, we don't do any of that. Out of the box, our focus is designing and building of a structure, of course, it can be fully electric, out of the box from the get-go, and that is the benchmark for us. So that folks have an option and the ability to add a renewable, and for the ability to offset energy consumption, that is. So this is, we'd like to walk through an example project with you all and give a little bit of a level of understanding of just what keys are offering, what's unique about our company, but more so what are the tenets of the design and the construction of our types of homes. Out of the box, like I said, it's a focus of electric heating. So this is actually a picture of a heat pump heating technology for an in-floor radiant heating system. And this technology, or this application here, is being used at 8,500 feet, I believe it is. So it's on a mountain setting. It's in a cold climate, and yet we're still able to pull heat out of the air. I think it's up to -10 or -15 Fahrenheit. Heating a liquid like a glycol, that brings it to a storage tank. That is, the heat's exchanged into an in-floor loop, and then that's put through the zones of the house. I mean, that is really superb that this technology exists. This technology actually this brand comes from Canada, I think, originally. And we use this on most projects that are looking for like an in-floor heating system. Again, the selling points to us is that it's electric based. The insulation that defines our exterior of all assemblies is a wood fiberboard. It's a wood-based material. It's a fibrous material. It's actually the recycled product of glulam or CLT production. I think it's mostly glulam. This material we actually procure and receive or import from Germany, like a couple other few brands, and we're looking for opportunities to work with the brand in the States. The point remains is that it replaces foam board for us. So it's a material that's the wood-based integration, and it's exterior to all of our wall and roof assemblies that are at the exterior. There's a picture here of that material. The picture at the bottom left is actually the inside of the wall. It just kind of gives a little bit of perspective of how thick the assembly is and what it looks like before drywall. Here's actually a picture of that material installed onto an exterior wall frame. So this is what it looks like underneath the membrane, underneath the furring, underneath the siding. Basically, it's a thick sandwich of material that it fully coats the exterior of a wall roof assembly, the exterior. Getting to the tenet of design for us is the ability to really thermally break the exterior assemblies in a cold or even a heating-dominated climate, allowing us to really reduce that resistance or reduce that loss value, so it's a high-value assembly. Another key tenet for us is that we integrate and support airtightness. Airtightness for us is defined as we can definitely hit values that are well below 1 ACH50. If we're familiar with what that terminology is, it just stands for 1 air changes per hour at a negative test pressure. If we're familiar with like a blower door testing rig, essentially you just depressurize the house with this door fan in the picture on the right. We can see that we can depressurize the house, get a program a volume of the space we're testing, get a flow rate of leakage, and apply it over the volume, and get then basically a miles per gallon, if you will, gauge of how tight the house is in the assembly, looking at it from the aggregate, the total picture, foundation, walls, roof, the entire thing, really focusing on values below 1 ACH50 or less is what we're after. Integrating also for us, what defines healthy housing, what's efficient, is once we've got this nice tight insulated envelope, this nice well-conditioned box, or this box, if you will, it's much easier to have ventilation and air efficiencies inside the house. I'm referring to something here on the screen is just a fresh air balanced ERV system. There's a couple different brands that are out there. We like the higher performing units, like this Ender is like a typical example. which means it's bringing air inside the house at the same rate it's exhausting air, and it's pre-tempering incoming air with exhausting air, so it's saving the heat that's happening, that's already been conditioned inside the house. It's filtering the air, and it's distributing it through the entire house. We have supplies in bedrooms and common spaces, and we have exhausts in like laundry rooms, kitchens, bathrooms. And when you have an effective solution like this, the ducts, you see the gray duct work throughout the house. There really is no match for a well installed and a great product like this that allows the house to be fresh air filtered, and the control of moisture inside of the home is really the key factor here. As air tightness requirements increase, we're seeing more and more this adaptation of going to a fully integrated. This is a ducted solution, which means it's its own system. So it's not a timed bath fan, right? It's not kind of a halfway solution. It's the fully integrated solution that assumes that we're going to be balancing and continuously operating this fresh air system, which it's really nice and effective way to keep a healthy fresh air inside the home. This is just a quick snip to show you what this house looks like from a consumption standpoint. We use energy in the winter months. We're making most of it. We're banking most of it, if you will, in the summer months. We have a grid tie agreement with our solar system here. This house, I think it's a 4 kW system size, and we're just about zero for the year, depending on exactly our exact usage. So we're proud to have this as an offsetting house based on electric utility. So that's a little bit about like our focus of company, where we direct our product. Now let's talk a little bit about the industry as a whole, and then I'll get to some of the steps as well. But talking about the construction industry, it's one of the laggards. If not, it is the laggard industry if we compare to industries like aerospace or healthcare or automotive. Productivity has been thin for quite a while, and that also translates into construction processes that are focused on a project-based approach, which I'll explain. Usually results in longer time to complete a project from initial start out, and a lot of projects, if not most, looks like 80% are over budget, which I'm sure we all have maybe some experience even in that case. So the typical traditional method of construction that we find in our industry is it's a project-based focus. This simply means that projects are planned from scratch. They're typically designed ahead of time. For the most part, most likely not using pre-designed components. And there's a disconnect between the incentive structure of how something is designed and built and then integrated and put together and assembled at the work site. Meaning it's the on-site world tends to be temporary, it's manual. There's a difficulty to connect the digital content throughout the entire start to end of the project. A lot of times working in many different softwares with many different fragmented teams without standardization or standard content. So this sort of disconnect or fragment really is when tested right now with high demand, it's an over budget, over timeline sort of result. And it's the current ecosystem, and it's rapidly changing. So right now the industry is in a disruptive state, which means it's quickly flipping to something which I'll present here in a second, a product-based focus. But some of the pain points too are skilled labor. We've got now basically a supply crisis. There's a limited supply of scarce materials, which means the prices spike, which means now we're again, continuing the trend of being over budget and late to deliver a project. Interesting enough, it's one of the bigger industries as far as GDP is concerned, so it's definitely an area of focus, and that's exactly where we focus as a company, talking about how we're working to solve that problem, how we're actively bringing a solution to the marketplace. That's really our step one to talk about today, is something where we refer to as introducing digital content. So let's talk about what that ecosystem of the future looks like. So we just described the historical construction industry as more project-based, where it's fragmented. The ecosystem of the future, the one that we're investing into and many other companies are, is a product focus, which means projects that you run through the system integrate pre-designed components that are manufactured off-site and designed explicitly to be assembled and delivered to the work site. Delivered to the work site, delivered to the project address, and assembled in a way that's efficient, on time, and within a cost basis that doesn't overrun. So some of the key characteristics here is where companies like us or many others specialize in a certain end user segment. They design a component library of details that then the designers, like an architect or engineer, work with or work within. And then that is a connected value chain where there's consolidation and standardization across the chain, which means that it's a connected, it's lean focused approach to construction, which means that you can forecast the total cost and the construction and schedule of something way easier and more effective because of that early investment and focus on a product-based specialization end user segment, essentially, with a library of components or details that are standardized. It's no different than aerospace and automotive. If you look at automotive industry in the 1920s, there was hundreds of car brands, if not thousands, maybe hundreds, that had kind of siloed work environments where they were developing their own project car, if you will, and model and selling it. What ended up taking place is, if we look at the auto industry as a whole, is it whittled down to essentially big three automakers that work with standardized content and use a platform of design, which is your typical car model as an example. And we have all kinds of efficiencies, integrations, where we can really forecast accurately what it's going to cost and how we're going to actually build something effectively, instead of a one-off custom or slower custom built nature type, which we're currently experiencing right now in our industry. So how we're going about this as a company, Phoenix Haus has developed something called the Alpha System. The Alpha System is simply just a standard breakdown of connections that define, for us, our focus is single family construction. So there's typically 30 connections that define floor assemblies, wall assemblies, roof assemblies, and how they connect and adapt to each other to generate a certain architectural form, if that makes sense. What we've standardized are the connections. It's also important to point out, which is a distinction between form, which we'll get into here in a second. But the key characteristic here is that what's integrated, which is the next slide here, is a performance metric, benchmarking off of what we talked about in the first few slides. What we're focused on as a company and other companies do is, let's talk about how we're going to really reduce the energy consumption down by 80 to 90%. Well, how do we do that? Well, we benchmark off of our climate. Our system is focused on cold climate housing in the Rocky Mountains is our business model. And those 30 connections, we've defined what performance values do we have to hit at those different connections throughout, or what defines a thermal boundary, a thermal envelope of a design, so that we can hit those key factors and then be able to hit those efficiencies, which then allow us to do things like electric heating systems. We can hit those lower sized systems, so we can look to offset something with solar, is really our objective as a company. So coming back again to the model example, we're talking about integrating those standard connections into something that we call a 3D BIM model, which I'm sure some of us are familiar with. BIM model stands for Building Information Modeling. So we take the standard connections, we program the architecture, we work within our constraints, and at the left is the digital fabrication model. Essentially, we're building the house always twice. We build it first in the 3D world, in 3D BIM. We make sure everything is fitting within the constraints, within the standard connections that we have and offer as a company. Then we integrate the required engineering that's happening at that work site, at that specific location, if it's wind or seismic or snow loading requirements. that's what's unique about this project, for example. And then we go to actually build the components that make up the house, which we'll get into here in a minute. So this is a trend, right? It's a trend towards digital content, and that being the focus and feature of the construction industry as a whole, where projects are investing into their emphasis or requirement of having things built in the digital world first. So that brings us to this graph, which means that the typical design workflow sequence is that construction documents, typically the documents that you're working to develop with architect and engineer, kind of happen later in life in the total construction timeline. With the new and revised approach with digital content, again, we're creating libraries of details, standard connections. We can work to bring that workflow way up to schematic level design, which is the traditional schematic level design, and really front load the design process to integrate the things that are going to make this product efficient and bring back this costly curve of design changes that typically happen later in life with the project. We bring all that, we bring it way up to the front. And that goes for any project that we work with and other companies like us. We're not just the one company. Again, yes, using fully integrated 3D dimensional digital twin BIM model. And then we use that as a way to make the process efficient. So that's, again, kind of a screenshot snip of what that looks like. For us, it's really about sharing the content. As far as like a process, if we're process minded here today, if we're thinking about what's the 1, 2, 3, first, a company like us has to open source share the content, which we do. So we share the alpha system detailing that's standard with our network, and designers, architects, folks that are working to generate the content, to generate the design for the customer, are working with our system, working with our constraints, and they work with that first. They have to have the content first before they can design the building. Then that content can be shared back with the home office, so to speak, coordinate with the rest of the project teams, and then we can finalize on the 3D BIM model. Really, we're agreeing as the entire design team, whether that's internal or external, on a fully integrated 3D BIM model. Essentially is the objective there. If we talk a little bit more about Phoenix Haus as a company, what we focus on, what we're finding success, it follows exactly what we just talked about, is that anything that we can integrate ahead of time, we're forward, we're after that as a company. A couple of years back, we, as a company, would build mostly custom designs, custom homes, custom models. As a company now, here in 2021, going into next year, we're integrating and working off of our Homestead model platforms. So we have roughly 7 different models to choose from. The point being, and why I bring it up, is it's talking about a certain design of an end user segment that then we work and build out on the back end. So what does that back end look like? Well, it's these things. It's the structural integration, the components that we can use as a company, so with things we can integrate in the offsite facility, and also importantly for us is mechanical integration, anything that's unique or different to this approach of construction, or things that we know that trip up the on-site trades, the on-site prescriptive installed mechanicals. I'm sure we've all seen it. If there's a mechanical design that needs to get integrated on site, if there's collisions that can occur, it's nice to know if you can work those out before in the 3D world, suss it out then, figure out where the collisions happen, make the corrections, figure it all out ahead of time, and then have a plan for when we're in the field versus vice versa. How we go about this for our different models in our product, the Homestead model product, is we've standardized most of the engineering details. So we took our standard alpha system connections, and we made sure we put some horsepower behind that with an engineering detail that's sealed or stamped or stampable for a certain specific geographic location, and climate. Again, we're focusing on the Rocky Mountains. For us, it's the connection details for floor systems, the exterior envelope, the roof, how we generate the roof assemblies, overhangs, deck attachments, floor attachments, the whole thing. So our coded system that architects, designers grab and work with the open source share to design the behind the scenes. What we have is coordinated structural content, which is extremely helpful when designing. You know what that looks like is here. Here's some visual representations of what that alpha system design looks like, and I've focused in here onto a component. I'm calling a window a component. You know, something that is basically either a subassembly or something that's not produced by Phoenix Haus but integrated into our package are windows and doors. And we like to, when possible, especially on our homestead models, is to pre-install windows and doors so that we can deliver the end user, the customer, essentially that airtight, watertight performance assembly, not leaving any kinds of gaps of the scope of package so that the on-site builder can work with the system installed in the field, which I'll show an example of that here shortly, integrating things like windows, which we feel is a very important key element of the performance envelope, is getting the air tightness correct at an opening. So we actually seal the opening 3 times when we pre-install a window. We do an exterior watertight connection. We do a gasket in between the unit and the rough opening. And then on the interior side of an assembly, we're doing another layer of airtight sealing. And so that always allows us, sets up the project for success to hit that blower door air tightness kind of out of the box. And we're really right now as a company, we're focusing on pre-installed windows. Doors at the moment are not pre-installed in our system. So that's kind of an example of what that looks like. We can see the window is in the opening. It's inset, just like those the standard documentation shows. It's got the airtight on the inside. You can't see the exterior sealing, but there's an exterior seal and then a gasket in between the unit and the opening. Further conversation about our models as a company is we focus on standard content as well from the floor plan perspective. So we have standard configurations for bedrooms that we reuse and can reuse to create a model option for a customer. Kitchen configurations also includes bathrooms too. So we know what works well for efficiencies when it comes to planning mechanicals. Also, just from a design efficiency standpoint, again, talking about standardized content, basically pulling from a library of details that make sense, things that we know have worked in the past. And so you can rapidly adjust or adapt a design based on how that house is sited or where it's physically located to make it work within the model platform. We also like to increase the occupancy of an investment. You know, I think ADUs are very popular. ADU stands for attached dwelling unit, essentially creating an entire separate private livable space in addition to the primary use of the typical single family home. We see a lot of ADUs being integrated into attached or detached scenarios. So is it a distance away that's on the property, or is it actually attached to the primary residence? So ADU options as well, which includes kitchen, bath, and like loft spaces as kind of like the smaller option. Typical range that we're seeing is anywhere between like 400, I think, to 700 square feet is like the typical kind of ADU range options for a lot of the houses that we work on. Kind of skipping away from standard architectural content would be also mechanical design. This is like a visual representation of what a pre-planned mechanical system looks like. It's a little rough. It's a snip of that mechanical system, but the green and the blue tubes are actually the fresh air and the exhaust or stale air for a house, just like we talked about at the beginning of the presentation. So here, the 3D BIM model is on the right. We make sure to run those exhaust or fresh air supply runs through the house, back to the unit, to the outside. And then we explore and make sure that we know if something's going to collide or hit a structural component, maybe it's a beam or a wall or even a floor component that's pre-built. So if we know those things ahead of time, we can make those provisions ahead of time in our panels that we're manufacturing offsite. So when the panels arrive, they're assembled in sequence. When the mechanicals go to install, we've already got the penetrations made. The accesses have already been created. It's essentially pre-laid out. This is what I'm talking about as far as the bringing up all that design work to the front loading it, doing all this work before we touch a stick of lumber or we break ground. It's advantageous to have this content and the work done ahead of time, and it's a visual share too as well for the on-site worker or installer. So the on-site trades can have a visual reference and breakdown of this as like a sequenced PDF, if you will, 2D PDF, or a breakout of scope of package. So what's the bill of materials for this mechanical? So we know what goes in when, and then making sure that it's totally, everything's there to be able to install this at the work site. So I'd like to run through how we actually would build a project, because I'm sure we're probably wondering, like, how does this actually go from a manufacturing facility in Grand Junction to the work site? So here is the start of the installation of the 1,900 square foot model. Really here we started with, as you can tell, a crawl space with, sill plating, if that makes sense. We had a mid-span support beam also set up before we started to install our panels. So day one really was, unwrapping and grabbing. I think there was like 6 or 7 floor panels. These are 30-foot long by, I think, 8-foot wide segments. So 8-foot width is the ship width and 30 foot's the length. And here we're spanning from end to end with the mid-support beam. That sort of install sequence allows us to set that floor probably like, in a couple of hours, which is really, it's remarkable time. Things that set that up for success, what makes the installation of these assemblies go smoothly, is the connection between concrete and our wood assembly. I mean, there's much to be said about getting the treated sill plate or the sill plating accurate. So it's square, it's level. It's actually referred to as a leveling plate. So whatever we put on top of that leveling plate or sill treated plate sets up the rest of the house for success. Even if the foundation is inaccurate or the concrete is inaccurate, which it most typically is, we can correct that error in that leveling plate, get that all sorted out before the first panel load arrives, before the labor even arrives to install the panels. That's actually the connection that we have centered. So you can see a little bit of what that looks like from like a design perspective. And then here is a visual representation of just the speed, right? So the start of that day, we had a foundation, which means in one day, the sequence of installation was to install the floor panels, as well as all of the exterior wall panels here in this picture. That's day one. So it can be a rapid installation. It's a technology that rapidly installs, basically is what I'm trying to say there, which means that when we invest into that pre-design and we bring up and front load the design, the benefit at the end is that when we have a little bit more money invested into the design, notably so, and like a crane, well, it's supposed to go quicker. So, it's typically taking maybe 2 to 3 months in the field. We're looking to do like in 1 week is the objective here. So here's day one. This is actually a real snowstorm that happened for days 2 and 3. So some of the pictures are missing, but days 2 and 3 was in filling and installing the garage area of the house, the upper level wall panels, as well as I think it was the interior floor system, that's right, and interior partition walls as well. So the photos kind of skip to the end. What we can see here in this photo, we had and installed a ridge beam in days 2 and 3 as well. Basically getting everything prepped inside to then be able to install the final set of panels, which I think was 12 roof panels. So that was day 4, maybe a little bit of day 5. And that's a little bit of the documentation of the pre-configured standard content that we use to build this model and these assemblies. And that's the complete scope of package by Phoenix Haus. So I'd like to just describe that a little bit to understand just the context of where we stand right now in our industry. We're not a finished product. There's some companies out there that do well, interior finish, maybe even exterior siding, and finishes in general, which is neat. We as a company, since we focus so much on the performance, we like to leave finishes off. so we can execute airtight, watertight seams and tape seams around the assemblies, and be able to achieve like a nice blower door test before we go to put on a finish, like a siding or a drywall. That's not to say that we can't have more integrations as a company to integrate things like pre-installed mechanicals, pre-installed wiring, pre-installed plumbing, pre-installed chases. We can and are doing that as a company. But as far as the finish level detail, we're not there yet as an industry, I don't think, because we would follow that industry kind of norm. But now we're focusing on something, we call like the structurally insulated, airtight, watertight envelope that it's installing in a short amount of time that allows the then sub-trades that get to continue on after us to work on the exterior of the house, the single-family house, as well as working at the interior for installation of mechanicals and finishes. I think that's key as well, because you can have basically an airtight and even heated interior enclosure any point during the construction calendar, because like here in this example, this was installed during the winter months on the Mesa. Once that enclosure installs, unlike typical stick built, we're fully insulated, and we're a version of airtight if we have the doors closed off with, like, say, a visqueen if the doors aren't installed yet. This allows us to turn on some heat and to work at the interior, kind of like speeding up that construction schedule like you'd expect to have a warm environment to apply or install finishes. And on the exterior side, siding and roofing can commence immediately. So we can get this, fully boxed in, working inside and out right out of the gate, which I think is really nice and a neat efficiency that we can talk about. So I'd like to kind of walk through a little bit of just what are some completed projects, what they look like from this digital fabrication to an image of the actual built project. So this is what we call the H15. That's it designed, that's it built. So it's neat that you're basically like digitally printing homes essentially, because it's fitting the form and the function of that system is to be able to really go from here quickly to the actual physical world. Let's look at another one. This is, I think, a story and a half. That's it in the digital fabrication model, and that's it existing at the work site. These projects, they're installing in a couple of days. I mean, let's call it a week to install walls, interior partition walls, floor systems, roof panels. Here, these few projects that I'm citing have windows pre-installed. Not all of them do. But we can see here in the images, we've got pre-installed windows. And everything also has a membrane, which means that's that black membrane. It gets taped in the field. That tape joint executes the watertight layer. So once we have an executed tape joint, like even on a roof panel, we're able to get this assembly out of the weather, quickly get it dried in, so to speak. So we can weather like a rainstorm or a rain event or like kind of a moisture event, if you will. And I'm pretty sure that the warranties on these membranes are we can leave it exposed like this for up to 6 months. Maybe we don't suggest that for the roof, but at least for the walls, I think that rings true. So it's neat to be able to get it to this level and then they push pause if we're watertight, airtight. There's another one that we're built, and this actually sent to Ohio. So this really speaks to the ability to ship products at a distance. These designs and builds allow when it's the right size, can be shipped, I think, very effectively on a standard semi truck, like drop deck semi. And we're doing this, to the Pacific Northwest, to the Midwest. We've sent projects. What's neat about the standardized content is that you can really handle well any kind of different code requirements from the different states. In this case, Ohio, or in the past we've done Washington State. So having the pre-designed workflow, having the modeling and the front loading of the design allows us to have a fully engineered building essentially. And when we manufacture and make these components, we're pre-inspecting them, or they have an inspection designation that travels with the panel to the work site, which means that building departments have confidence that when something is arriving, even if it's covered up, so it's a closed panel is what's referred to, we can still have the ability to have confidence that this can assemble within the requirements of the building department. That work has been done ahead of time and sussed out in the design. So at the work site where somebody just assembling the parts again in the field, and then executing a final structural inspection once the panels arrive and are erected. Another thing to point out on that thread of inspection is because we have a fully watertight exterior assembly, and we focus on airtightness, we bring actually the shear layers to the inside, which means all the mechanical connections for the house and for the panels happen on the inside, on the warm side, which means all the work to wrap up installation of hardware and have the final structural inspection can happen from the interior perspective, which is really helpful. We don't have to climb around the exterior of the house to put these panels together, basically. They're attached with essentially a cocktail of structural screws, all from the inside, except for the ridge line of the house where the screw is attached to the ridge timber. That's something that's also, and it's neat to point out that means that work can be done on the inside, on the warm side or the watertight side, to punch this out and to make this work well for final inspection. Yeah, here's an example of like how something actually gets shipped. We ship something as like what's called like a wall bundle, or like a wall or roof or floor bundle. We've standardized the shipping to fit onto commercial trucks, like a step deck truck is typically what we're using. And we're doing that via a design that's linked to the 3D BIM model. We essentially say we're playing a game of adult Tetris. And we're trying to always, and we make it work where we fit within the shipping constraints of height and width. Weight we're not too concerned with, but when it comes to height, it's typically 13'6" is the max height, and then an 8-foot wide. So when we go to design a house, we actually work backwards from the shipping model, so that we know that we don't design the walls to be too tall or too wide. Same thing for roofs and floor assemblies. Everything has to fit on the truck. We bring that back to the ability to make something in the offsite workshop. Here's just some more pictures of, again, these are pre-installed windows, site-installed doors. So here we have a pre-installed window that came within the panel. It was part of the airtight, watertight layer. And there's some final detailing that happens at the work site, which is a metal sill pan by this brand of manufacturer window. Again, we have a watertight assembly. The interior is already airtight except for the panel seams that gets executed at the work site, air sealing at the panel seams. And again, it's the same thing where work can happen immediately on the inside and exterior of the building once it sets. Just some nice kind of different angle pictures of what an assembly actually looks like with a pre-installed window. Here's the inside perspective of basically that same type of wall panel. In this case, it's a triple pane window and door. This is a wood clad product. If you can tell, it's inset in the middle of the wall, just like the window detailing from our standard alpha system details dictate. It's also showing you, this picture is how we focus on airtightness, that we seal the panels in our factory at all the panel joints, and then the panel joints that happen in the field are sealed and taped at the work site. A couple more pictures here of what our scope of package typically is. So we have, again, exterior wall panels, but we also can bring something like partition walls, floor systems, and even like loft kind of mid-span walls like we see here at the top of the picture. The important part is that we're looking to find ways to make sure that the sequence of install can still be efficient. We want to offer the value of essentially a framing trade. So we'd like to bring partition walls, floor systems, which allows to offer like a full scope of package. The install efficiency means that we don't hold up the roof insulation, so like the roof panels, because we're having to stick frame a partition wall or a floor system. We'd like to avoid that, so as to really, install sequence something in one go. Again, looking to do it in like around a week or so for these kind of smaller 2,000 square foot size projects. We also like to integrate and work with and design in the digital model any kind of steel, or in our case, we like to work a lot with glue lam or structural components. Like I mentioned, talking about how we work with ridge beams. This is an example of like a midspan or a ridge beam, where a panel structure is sitting on top of a ridge beam. The important key metric here, the characteristic, is that the beam itself is pre-processed off-site, just like our manufacturing facility. So we work with a couple different manufacturers that are located in the Rocky Mountains that actually pre-process timber with the inputs of the same 3D BIM model, which is amazing if you think about it, because it's another component that gets designed in 3D, integrated, pre-processed, and installed in sequence, exacting tolerances for the install sequence. That's really important to bring up, because that means that the entire structure of the home is part of that digital fabrication package. And we're using things that are standardized, which means we have standardized glulam sizes that we're working with to integrate in the design. That standard connection pockets into our wall. We have standard connections as far as how the roof sits on top of the glulam beam. The hardware to attach the roof to the glulam beam or to attach to the wall is also standard, which means, as you can probably see that I keep repeating the same word, standard, is that now we're talking efficiencies. Now we're talking about how that informs a product, which is the efficient install of this type of end product segment, which is single family, low energy use housing, like we described. A couple other pictures here, just, again, the digital fabrication model, and then and then reality. So the real life scenario here. Again, it's always the reoccurring same assemblies. It's the same buildups for a cold climate. It's just that we can adapt it to different architectural form. Here we have a typical gable residence with a shed roof alongside a pole building that was going to be not part of the condition envelope. So it's a thinner wall package. The point here is that we still have pre-installed windows, and it's installed at a site that has a very a short time for install. This is here in the mountains near Crested Butte. So there's probably a 5 to 6 month, window for construction. This was shipped and installed within a matter of, I think, 7 days. Something that's typically taking maybe 2 to 3, maybe 4 months on site just to get dried in. Finally, it's worth mentioning and showing a picture that we're using, again, CNC technology. So we connect the 3D BIM model, again, that looks like this, with an output that speaks to our equipment that's either manual or semi-automated. The ability to bring the digital content to a computer-guided saw is really key. It means that it's universally accurate every time, so it's processing the part, within a cut tolerance, and that every piece that we work with to generate a package like this is pre-processed on a CNC saw. So we know that when something is being cut ahead of time before it gets assembled and manufactured on our offsite tables here at the facility, we know that everything as an input is going in as an accurate cut each and every time. And that there's the ability to inspect material, to cull material, to cull wood, so that we reject things like warped boards or cupped boards or twisted material. So there's a quality process there that really we can plan and then also use that culled material, the reject material, as inputs to another process. So our waste factor is very low as well as an offsite manufacturer. We have very little waste. We reuse pretty much every material. And the material that we do have, it's wood-based, so it's not a detriment. It's not like we're throwing away really bad material if we do. Most times, cutoffs and wood can be used for other purposes. So that's, it's good peace of mind when someone's talking about how to build a house using this type of approach or technology. Now with that, I think, we can open it up or ask a few questions. Jim, I think that pretty much is, the breakdown of the presentation. Yeah.
Wow, Bill, thank you very much. That is fantastic, and we do have a lot of questions. I'm going to invoke my SECRES prerogative and ask the first one. I was particularly intrigued by your use of the recycled wood chip exterior insulation, which also eliminates the the greenhouse gas footprint that comes with polystyrene and polyisofoams. What is the R value per inch of that wood-based insulation that you're using?
Yeah, typically I think it's right around 3.4 or 3.5 per inch, if I'm not mistaken. So if you express that over the board, the material itself is typically 2 3/8 inches thick. So we're looking for an R factor of somewhere between, like, I think 8 and 10 on the exterior, if I'm not mistaken.
Excellent, thank you. We have, folks, we have about 40 minutes and a lot of questions, so I'm just going to jump through these from top to bottom as quickly as we can here. Does Phoenix Haus consider the use of geothermal heating?
Yeah, I think, geothermal is definitely an application of technology that definitely works with these houses. That's what's nice about this building standard, or the way that we go about it, is however you want to cover the heating or cooling loads of the house, no problem. I think the benefit here that we bring, or this technology, is that it reduces the total amount of heating and cooling load. You can use more efficient appliances, but yeah, that would be a suitable approach for heating or cooling, sure. Yeah.
Are you willing to quote a rough dollar per square foot for build without site prep?
Sure. If I can kind of talk about costs in a couple different ways. Our system here, like you saw, our scope of package is, it's trending around like $100 to $110 a square foot of finished floor area. And then realizing that's just the scope that's here on the screen. But as far as like finished construction costs, it ranges off of the market. If we're talking about Denver or Grand Junction, we could be in the $300 per square foot finished. But we're seeing it definitely turn up to somewhere in the 4s and maybe even the 5s in the mountain markets. Dollars per square foot finished floor area. Yeah.
Thank you. Can you talk more about in-floor heating? I understand a benefit for heat pump is lower temps are needed than for forced air system. What are other benefits?
The really nice thing about the in-floor heating system is that it's a very even heat. It's consistent. When it turns on for the season, it sips energy, and there's not these dramatic changes in temperature. You can set it at your set point that you like, and it's a very even heat. It also eliminates dust. I mean, if you think about it, air source based heating and cooling systems require you to move air to heat or cool something. Here, we're talking about you're heating up a surface, and it's a liquid that's happening behind the scenes. So it's a cleaner, more even heat, I would say. Yeah.
How does your approach impact construction waste? And I would add to that, or just ask if you could divide that between on-site and at your factory.
Yeah, I mean, breaking it down first with the factory it's like what I was talking about a little bit, is that you can actually plan waste, which means that if you have a programmed cutoff, if you will, because cutoff is inevitable, meaning if you have a bunk of wood and we want to go make some walls or some roofs, you're going to have cutoff material after you've made your cut to make that assembly. But we know actually what that cutoff is going to be because it's been designed in 3D. So we can forecast the amount of cutoffs we're going to have and then use them somewhere else in the project or the other uses around the shop. We like to use cutoffs and excess material for the ability to ship something safely, which means we block out and use the extra pieces of wood to be able to ship something and put it onto a truck. So we have its uses there. Same thing with like OSB or plywood. We're constantly recirculating a cutoff, maybe even to the next panel, and you can actually plan that waste. So that's in our factory. Now on site, the implications that we have is that effectively on site, there's essentially no waste, right? That you send this offsite package to the work site, and essentially you're just unwrapping it from its shipping plastic, essentially, and now we're just essentially assembling that thing in the field. So we should have very little or no waste in theory. The only thing that we have talked about as a company is when we ship something, it's in that plastic, is that you could take that plastic that's being used and you can just do a recycle process with that as well, like a recycle dumpster, or have ways to recycle that material. So that's what we're seeing as far as how, in comparison to the typical on-site trades, which it's difficult, is that if you're sent that same bunk of lumber to the work site and you have a cutoff, I think it's very difficult to reuse that somehow, because you'd have to have some pre-planning or some pre-thought as far as where do you want to put that cutoff. So it ends up being that inevitably you will have dumpsters full of cutoffs, waste material, what's crazy, because it's like, well, we could use that if we had an offsite manufacturing process. Yeah.
What materials do you use for foundation insulation? Is the foundation wrapped in that insulation?
Yeah, good question. So there's not a requirement. There's not a hard line of the type of insulation that's required to do like a foundation. We see a lot of EPS foam that's used below grade, just for the pragmatic principles, the fact that it can get wet. You know, EPS foam in itself, it won't degrade with any kind of moisture issues or challenges. I have seen you can use like a Roxol, Roxol is it's a cement-based material that can be used below grade if you're not for the foam. So there are foam alternates to below grade scenarios, yes. I think there's also another really nice company or brand out there called Glavel. I think Glavel is it's some type of is it fiberglass, or it's a non-foam based material that you can use to put a foundation together. So there are foam alternates. Here in this picture is an EPS ICF.
Your Homestead 21 shows a large overhanging roof. Is this custom sized to match winter, summer sun for the location? And I would add to that just if you could talk the bigger picture about passive solar embedded in your design.
Oh, totally. That's a good question. You know, this overhang is speaking definitely to the aesthetic of the house design itself. So we have other models where there's gable roof assemblies, and it's really more just going for the aesthetic look. You're right. It does have the benefit of allowing it to be used as a shading object for the upper windows. You know, out of the box, I can tell you that, you know, from a passive house perspective or the passive solar perspective, we do pragmatically do our very best to not overheat a house based on where it's specifically located, but there is site adaptation requirements for the design to do just a siting and lighting study, if you will, of where, you know, which direction is the house facing, what is the potential ability for overheating, and then being aware of those openings on the south and western facades, and then having a shading object or a solution to be able to not overheat. So what's integrated is the ability to shade some of the windows, but it's definitely a site-specific study to make sure that this does not overheat. Overhangs can be used, porch overhangs even, but also interior shades can also be used as a shading technique as well. That's pretty effective. Yeah.
Are you exploring or looking at any wood alternative options? If so, what? And how fire resistant is the end product?
Yeah, I mean, as far as like a wood alternative, you know, where my mind goes is if we go from like dimensional material to like engineered material, I think is kind of how I think about that. Meaning we can find ways to use engineered material which actually uses less virgin wood, if that makes any sense. So we're actually making a product out of something that's not as, you know, maybe the original tree product, if you will. Like things like glulam CLT, you know, tend to use 2x4, 2x6 is the input, versus using like bigger timber like 2x6, 2x8, 2x12. As far as like fireproofing goes, we see folks when we're in a fire area where it's prone to fire, is they tend to do a metal siding, making sure that any kind of venting around the assembly has a core vent installed. So it's ensuring that there's no way to suck any kind of embers behind the siding or cladding. So it's typically metal siding, metal roofing. And we've had to make sure that the design can integrate a fire suppression system. That's been the two ways that we've handled that.
This is definitely an important question for the mountains of Colorado. Has Phoenix Haus encountered problems meeting wind load design requirements?
You know, we're always aware of what the requirements are per the project site, since we're fully engineered, meaning that there's an engineered detail that's site specific each and every time, and it gets checked no matter what. we've been able to accomplish our builds in the mountains without any, without any challenge. Now, can we build, 10-foot overhangs in Steamboat? Probably that would be difficult, but it depends on the exact site. So the key characteristic there is making sure that we always work with our engineer each and every time at every site. And so far, we've been able to build, pretty much every location without a concern. Yeah.
Let me read this question exactly as it's typed. We may need some clarification. Gutex or Styco external installation. I don't know if it's asking whether you look at that or you use any of that.
Yeah, there's probably referring to the different brands that are available. There's many different types of brands. What we look for there to answer the question is we can work with them, and we do. We just look for the density properties and thickness. So we're looking for a consistent density of material that has the same ratings. We're going for something that has a good perm rating and a good R value. So it's not too dense, but it's not too, I guess you could say, less dense, and it's not too thick. So we go for something that's middle of the road that works well. That's standardized content for us. That's 60 millimeter, and I think it's a 140 metric on the density side, which is a metric valuation. But we work with more than one manufacturer as long as they can hit those parameters.
Does your heat pump cool also?
Yeah, that's a good question. So you can actually design with that heat pump technology to add a chiller. Essentially, you would take cold. Yes, you can take and create cold water in the summertime from this unit, and then attach it to a heat exchanger inside the house, which can convert the cold liquid to cool air inside the house. Yes, Arctic Air does have an option for that. So you don't have to invest into two separate systems, assuming that it works within the parameters of max cooling output.
The packaging and wrapping used during shipping seems to be a bit too much. Couldn't you load then wrap? Why use so much wrapping material?
Yeah, a good target for us, our goal as a company, is to use a system where we actually don't use any plastic. There's systems out there that we can invest into as a company that essentially are, it's a reusable tarp that's installed onto one of our trailers. The requirement there is, of course, is to purchase that tarping system. I think it's called, or referred to like as a Conestoga covering system on top of a trailer, in addition to having many of these, what they're referred to as like swap bodies to be able to load. So there are ways to invest into eliminating the use of plastic. For us, it's just the ability to be able to afford that technology or to afford that solution. So it's a goal that we have as a company, and we're very aware of limiting the use of plastic.
What approach is used to minimize thermal bridging at the field joints for the panels?
So everything is actually sleeving, and I'm trying to see if I can find an example. Excuse me if I skip fast here. I'm just going to go to my detail. Every joint around the thermal envelope has a sleeve connection designed in, which means the fiberboard in this case, and this picture on the left side of the screen, is designed where it's actually overhanging the stud assembly, which means it's a male to female connection all the way around the assembly. So there's no exposed joints anywhere on the exterior when we use our system details. So it's a sleeve male to female connection, so it does get covered up. It does get insulated continuous.
Is there any caulk used in that before you join those panels?
You can do that, caulk or gaskets. We rely a lot on that on the interior perspective. So we seal and tape the interior, in this case, plywood or OSB. So not at the moment, but yet you can, and we do tape most times on the inside.
Next question. I know you're using Alpen high-performance windows from Colorado, which are excellent and local. Have you considered lower price units like the Polish windows imported by Denko or others? Several European manufacturers exceed the performance of Alpen.
Yeah, we are. We like to say that we're agnostic to the window and door choice. for us to pre-install something, we have to thoroughly understand the requirements of that window and door system before we can offer it as an installed scope of package. I'm thinking that if it's a similar window style design and installation theory of brackets inset, it's something that we could definitely, include or add into a scope of package, sure. Some of the reasons that, like Alpin, for example, you see us using is also because the order lead time from the procurement standpoint. When someone places an order, when we look to offer a pre-installed scope of package, we like to have those as inputs to the manufacturing process. So the shorter lead times are advantageous, but not, those other window brands most likely work and are similar install? Yes. I think for us, we're always thinking about it from a timeline perspective. So, yeah.
Has the R value of the installation board been certified by the Federal Trade Commission's mandated ASTM C16 testing to be able to prove compliance with the R value minimum in a building code?
We work with the manufacturer's test sheets or cut sheets, if you will. I know that the way that we're thinking about performance and how we verify it is we go through and have this system, we call the Alpha system, certified through the Phoenix Haus Institute. Those folks, the Phoenix Haus Institute, took a look at the material, break it out into its different parts and components, and certified it this way. So I'm sure that this certification translates into the requirement that you're referring to. But it's a good question. I'm not sure how to answer exactly to the standard that's being referenced.
Besides the ability to have chases pre-built, what about plumbing and electrical connections in the panels and the use of pre-made conduit?
Sure, that's a great question because it's something that's on the horizon for Phoenix Haus. As we move into our new facility, the new HQ, we like to refer to it, we'll be going into version 6 of our system. 6 means like it's the sixth version of it, kind of like a software technology. So at the new facility, we'll have the ability to stand up our assemblies in something called the gantry. The gantry allows us to hold something vertical and to finish it from both sides. When we have that technology, we can start to integrate electrical and plumbing, at least rough runs to get 80% of the way there, and start to offer that to our customers so you can take some of that work that's happening in the field and pre-install it on the assemblies, yes. So see it coming online for version 6 in the new facility. Yeah.
My understanding is most prefab inspections happen inside the manufacturing facility. Is that the case with your process and products? Please elaborate.
Yes, it is. Right now, actually, something called an ICCES report, which means soon here it comes where we don't have to actually have a physical third-party company come and inspect. We handle the inspection process, yes, to answer the question. How we're currently doing that is via an in-person third-party designation inspection, yes. So we have every panel gets inspected every frame, which means there's an audit report that comes along with the order, and that goes along with the submittal to the building authority. And so what I'm referring to here for next year is we'll have something called ICCES evaluation service. We'll have the ability to, you could select the Alpha system in a code, an area where a building is being built. And when we follow a quality process of manufacturing in our own internal audits and internal inspections, we actually will not have to do that here in the future. But right now we are physically inspecting every frame, yes, in person.
So next question, is all the design work done via SketchUp, or do you need other CAD or BIM tool sets to design and architect?
Yeah, no, it's the system itself is exportable and can work in pretty much any architectural software. We have a lot of designers, architects that work in ArchiCAD, Revit, AutoCAD. It's pictured as a SketchUp part, but that's just only as a visualization tool. It's accessible. It can be used in many other softwares to be designed with. Yeah.
Next question. Developers like Lennar seem to think that Americans want pseudo-quaint cottage-style homes with tons of ridges and alcoves. Passive houses are near impossible with interrupted wall surfaces. What do you think of, I'm sorry, do you think those consumer expectations or tastes will change?
Yeah, I mean, I think when it comes to the design, we talk a lot about what would work to an acceptable level of either the consumer's taste or like an HOA or what the requirements are for like a neighborhood. If we have to jog an assembly or do a dorm or bump out, we can with the system. It just further derates the performance, and we can back that into the energy model of the home to make it perform. Said another way, we can get houses that have more jogs to perform. It's just more work on the design end. For us, we do run into many HOAs that we have to change the way that the house looks and the way it's, how it presents itself on the streetscape. But we can integrate those requirements early on in the design process. As far as the approach that we're going as a company, we like the cleaner aesthetic. We like the clean lines. We like the simpler forms as long as it's done tastefully. But we can't handle and have built the more complex if required. Yeah.
Have you done any CLT projects?
CLT and glulam material is close to our heart for sure as a company. We love working with wood, and that fundamentally is what we're referring to when we say CLT glulam. We work with a lot of glulam beams and structural components. We've yet to install CLT as like a floor or roof material, like a spanning, structurally graded material. But there's no reason why we couldn't, to answer the question. And we actually have some really great connections in the Pacific Northwest of both manufacturers and fabricators of CLT and glulam. So if there's any interest kind of after the presentation looking for a resource of that, please reach out and we can connect you if you'd like to see a supplier or a company that does that.
Just in case there are others like me that don't know what CLT stands for, could you define that acronym, please?
CLT stands for cross-laminated timber. So it's literally just like what it sounds. It's where you put different pieces of material together in like a sandwich, and that's a manufactured product that gets glued, and it's a heat-treated process that makes a stronger structural assembly as it's coming together, kind of like what's on the screen there. That's the glulam that's on the screen right now. It's similar to that.
How does your product work in the multifamily apartment or hotel world? Is that feasible? Do you have any experience in that space?
Yeah, I mean, when it comes to the multi-use or the larger scale commercial building, there's no limit to its use. We top out from a stories perspective 3 stories. Then it turns into probably a different theory of design of engineering. But we can build a bigger commercial building. So there's not a limit there to the offsite. From the offsite perspective, no. We've not yet built a hotel to date or like an apartment complex, but we have built neighborhoods.
Can you talk more about the German wood-based insulation material necessary? Looks like it makes strategies like double stud walls unnecessary.
Can you say that one more time, Jim? I think it delayed a little.
I think he's referring to. I think he's referring to thermal break strategies there. Using that outer cladding to generate your thermal break rather than a strategy like a double stud wall.
Oh, right. Yes. So we choose to do the exterior assembly with the fireboard insulation because we can integrate it into an offsite building process that can scale, if that makes sense. So making a double stud would be challenging from an offsite production lens. Working with a framed approach like we do is the more scalable option with current production equipment. And installing exterior insulation is a relatively easy addition to a production process. Yeah.
So that was the last question. I'll leave it open here just for another 30 seconds or so if anybody has any last minute questions. And yes, we have one came in, but first let me congratulate you, Bill. I think this is the most questions we've ever had for one of our guest speakers. So your lecture has generated a lot of interest. And there is one that just came in. Have any of your houses been HERS rated for performance? What score did they get? Do you offer an energy consumption guarantee?
No, that's a really good way to ask the question. What we have done is a FIAS rated or PHI certified projects. With that, to my knowledge, I'm pretty sure FIAS is requiring a HERS rating. But at the end of the day, I know that it's been 0 on a few projects because of the ability to offset with the solar system that I was showing a little bit earlier on the slides. So can easily do the 0 and do the offset with the solar. As far as the energy guarantee, so if there's a energy model that's created for the project, we definitely can guarantee performance. As long as we are assembling it as it's designed in the field or building it, like we say in the field as it's designed, you can definitely hit the performance within a 5% accuracy for sure. Yeah.
But of course, you never have any control over homeowner behavior. So to some degree, an energy consumption guarantee would be almost impossible.
Yeah, that's a good point. Thank you for that. That's a good lens. I think when I think about it, I'm thinking as, what's your benchmark that you're going for energy consumption from like a lights, heating and cooling? How does that structure perform if we're agreeing on a set point? For sure. Yeah. So like in an agreed set point. Yeah.
So another question popped up, which I was actually going to approach you about offline as I work on the building committee for Pikes Peak Habitat for Humanity. But have you been approached about working with affordable home builders?
I'm sure the questions come up a few times in our past. We're very open to it. Just straight away, we're very open to any ideas where we can help folks or a cause. That's really our interest. If you saw the design of these houses to have multi-occupancy or multi-use, trying to find ways to reduce the cost of housing. It's near and dear to our hearts as we see costs increase. But very open to it. Would love to participate, and I think it would be a great thing to work on. Yeah.
That's still an area I'm going to contact you about offline. Another question popped up. How thick are the walls and the ceiling/roof?
Yeah, so the walls are right around like 1'2", 1'3" and some change, like 1 foot 3 inches, 1 foot 2 inches. That essentially is though our rough system. So you still have to add drywall, and you still have to add like your siding or cladding. So let's just go ahead and call it like almost 1 foot, 4, 1'5", maybe even 1.5 foot thick for the wall. On the roof assembly, it's close to 2 feet overall when you apply the finishes. The base is typically a 16-inch I-joist assembly with a 2x4 interior and a build-up exterior to the fiberboard that varies in thickness. But I would typically say on average it's 2 feet thick for the roof assembly.
And so does that take you up to about an R60 or so?
We shoot for 70 in most cases, and 50 in the wall is really a target when we're really going for the full system dialogue. Yep.
That's all the questions on the board. Bill, I can't thank you enough for taking time out of your extremely busy schedule to speak to us tonight. This is great. To everybody that is still on here, just a reminder that this was recorded, and once it's cleaned up, it will be posted on the CRES YouTube channel as well as the CRES website. And Bill has graciously offered to provide his slides to anybody that wants them. And what I'm going to do in the chat is just give everybody my email address. And if you email me, I will send you a copy of the slides.
And yeah, I just want to say thanks again. This has been a great opportunity for us. We're always happy to connect with your group and we're very thankful for the invite. And thanks so much for having a chance to talk with you guys today. Yeah.
And thank you for ending our 2021 guest lecture series with such a fantastic lecture.